Excel A-Level Mathematics C2. Use the factor theorem to verify that x minus 1 is a factor of the polynomial p of x equals x cubed plus x squared minus 6x plus 4. We then have to factorise p of x completely and find the exact solutions of the equation x cubed plus x squared minus 6x plus 4 equals 0. First of all, let's remind ourselves of the factor theorem, because that's going to be useful in proving that x minus 1 is indeed a factor. So it says f of a, so some numerical value a, equals 0 only if x minus a is a factor of the polynomial f of x. Well, in this case, the polynomial p of x is x cubed plus x squared minus 6x plus 4. So therefore, we have to try p of, we're given that x minus 1 is the factor, so just simply p of 1. Not p of minus 1, p of 1. Okay, so we're going to sub 1 in. Wherever there's an x, we'll sub 1 in for it. So this is equal to 1 cubed, which is 1, plus 1 squared, which is 1, minus 6 times 1, which is minus 6, plus 4. And now we can just add up all the numbers. 1 plus 1 is 2, 2 plus 4 is 6, 6 minus 6 equals 0. So therefore we can say that x minus 1 is a factor. And now what we're going to do is we're going to find out if there are any other factors there. We may find 2 more factors, we may find a quadratic factor, but we'll do this by long division. So we'll simply divide x minus 1 into x cubed plus x squared minus 6x plus 4. And so what we're looking to do every time is remove one of the elements of the function itself. So we're trying to remove the cubic part now. So what we say is, what do you multiply x by to get x cubed? And you simply multiply that by x squared. So we'll put that at the top, and then we'll multiply each time by x squared and put the result underneath and then subtract from above. Let's see what happens. It'll make more sense when you see what happens. X squared times x is x cubed. X squared multiplied by minus 1 is minus x squared. And now, just with ordinary numerical long division, we subtract this line from this line. X cubed minus x cubed, 0. X squared minus x squared is the same as x squared plus x squared, so that gives us 2x squared. And then we bring down the next term and start the process off again. What do we multiply x by to get 2x squared? We multiply it by positive 2x. So we can put that at the top. Now we multiplied 2x by x, giving us 2x squared. Write the answer there. Followed by 2x multiplied by minus 1, which is minus 2x. And again, we subtract the bottom line from the top line. 2x squared minus 2x squared, 0. Minus 6x minus 2x is the same as minus 6x plus 2x, which is minus 4x. And then we bring down the next term. Start the process off again. What do we multiply x by to get minus 4x? We multiply it by minus 4. Minus 4 multiplied by x is minus 4x. Minus 4 multiplied by minus 1 is plus 4. And we can see that when we subtract the bottom line from the top line, we're left with no remainders. And so what we've got so far is x minus 1 is definitely a factor of this cubic function. But also we've got a quadratic as another factor. We've now got x squared plus 2x minus 4. The next thing we need to do is we need to see if we can factorise x squared plus 2x minus 4. And so now we've got to factorise x squared plus 2x minus 4. Well, we know if there are any integer values which are factors, we will have to multiply the coefficient of x squared by the constant. So 1 multiplied by minus 4, we need to look for the factors of minus 4, which are 1 multiplied by minus 4, minus 1 multiplied by 4, and 2 multiplied by minus 2. Now, when we know that all of those are going to give us minus 4 when we multiply them, but importantly, when we add each of the pairs together, it's got to give us the coefficient of x. So that if it adds up to 2, then we can choose these values and replace 2x with whatever they are that add up to 2. But let's see what happens. When you add 1 to minus 4, you get minus 3, so that would in effect give us minus 3x, which is not what we want, so that cannot be used. Minus 1 plus 4 is 3. Again, we want 2x, not 3x, so that is not useful either. 2 minus 2, let's make that minus a bit better. 2 minus 2 is equal to 0, so that's clearly no good either. So therefore, we don't have any integer values that we can use. So what do? We can use the completing the square method to find the roots of the equation. So first of all, let's make that an equation. X squared plus 2x minus 4 equals 0. That turns it into a quadratic equation. Now we can simply manipulate this by adding 4 to both sides. We've got x squared plus 2x is equal to 4. Now the reason for doing that is because this is a nice the left hand side is really nice to turn into a perfect square. So by halving the coefficient of x, we can say that x plus 1 all squared is going to have x squared plus 2x as part of it when it's expanded. Let's just expand it to see what we need to do on the right hand side though. X times x is x squared. X times 1 is x. 1 times x is another x, so plus 2x, and then 1 multiplied by 1 is 1. So when you expand x plus 1 all squared, the perfect square x plus 1 all squared, you're left with x squared plus 2x plus 1, which is not what we started with. In fact, it's 1 bigger. So in order to make this this equation true, we need to add 1 to the right hand side too. So therefore we can say that we can use the perfect square x plus 1 all squared as long as we add 1 to the other side. So that's not 4 anymore, that is now 5. Okay, now it becomes to be a little easier to see what the roots are going to be. All we need to do now is square root both sides. So the square root of x plus 1 all squared is x plus 1. And that is equal to, importantly, plus or minus the square root of 5. And then we simply subtract 1 from both sides, so we found out that the roots of x are x equals minus 1 plus or minus the square root of 5. So we've just calculated that x squared plus 2x minus 4 implies that x equals minus 1 minus the square root of 5, or x equals minus 1 plus the square root of 5. In the original polynomial, p of x is equal to x cubed plus x squared minus 6x plus 4. And we already found out that one of the factors was x minus 1. But the other two factors now we've also got with these values of x, so or we can work them out. So that's going to give us x minus some value of a, which we'll call a1, multiplied by x minus some other value of a, which we'll call a2. Now, remembering the factor theorem, a function of a equals 0 if x minus a is a factor. So x minus a1 is a factor and x minus a2 is a factor. So the factors are going to be x minus 1, and then we go to here, which says x equals minus 1 minus the square root of 5. So the factors, the other factor will be x minus a, because a has to equal that, which is minus 1 minus root 5. And then that will be multiplied by x minus a2, which is x minus 1 plus root 5. Now we can simply expand brackets and make it look a bit tidier. So x minus 1 is plus 1, minus root 5 is plus root 5, and x minus 1 is x plus 1, minus plus root 5 is minus root 5. And there we have the three factors of the polynomial p of x equals x cubed plus x squared minus 6x plus 4. It's just a little bit tidier there, so we'll put a little square around that. Sorry, a little rectangle. But on the right hand side you'll see that there's a graph of the polynomial. Let's change the colour of the pen to blue. You'll see that this point here represents x equals minus 1 minus root 5. Root 5 is just over 2 in value, so that's it's about 2.24, so that's going to be 3.24 there, round about minus 3.24. Here you've got x equals 1, which is what we get here. So x equals 1 at that value, and at this value here, this curve just dips beneath the x-axis. So this other point here is x equals minus 1 plus root 5, which again, root 5 is about 2.24, so minus 1 plus 2.24 is around about 1.24.